New section, we're dealing with systems of equations in 2 and 3 variables. So one of the things we want to know up front is this point a solution of this system? In other words, does this point lie on both of these lines? So the way that we're going to figure that out is just by direct substitution. So I have an x and a y here. This has an x and a y. This has an x and a y. So we're going to substitute in and see what we get. So when we substitute into the first equation, we get 2 times 7 plus negative 5. Does that equal 10? Okay, 2 times 7 plus negative 5, does that equal 10? So rewriting this, 2 times 7 is 14. I can write that as minus 5. Does that equal 10? No, it does not, because that equals 9. So honestly, we can stop right there, because this point is not on that line, which means I don't care if it's on this one because it's not a solution to both. So this one, it is not a solution to that system of equations because it's not on both lines. So I'm not going to waste my time trying this one. So now that we know what it means to see if a point is a solution or not, we're going to actually find a solution. So in this case, we're going to use substitution. So if you'll notice, the top equation, I really like the fact that this x is just sitting here by itself. It doesn't have a coefficient. It's just 1x. So this is going to be pretty easy to use substitution with. So what I'm going to do is take this first equation, and I'm going to get x by itself because it's easy. And so that means I got to get rid of my 3y. So I'm going to subtract 3y from both sides. So now I know that x is the same thing as negative 3y plus 5. And I got that from the first equation. I can use that information in the second equation. So let's see what happens when we do that. And just for tracking, I'm going to change colors. So instead of writing 2x plus 3y equals 4, now what I have is, well, I know what a different value for x is, or a different way to write x is, and that's a negative 3y plus 5. So instead of x, I'm going to write a negative 3y plus 5, and I'm going to keep writing the rest of the equation. Okay, so now notice, instead of having x's and y's, now I just have y's. And I know how to simplify to get y by itself. So I'm going to distribute my 2. So again, the right side is as simple as possible, so we're going to work on the left side. So 2 times negative 3y is a negative 6y. 2 times 5 is 10. Plus 3y is 4. So I'm going to put my y's together. Negative 6y's plus 3y's is negative 3y's. And the rest stays the same. I'm going to subtract 10 from both sides. So now I find out that negative 3y is going to be the same thing as negative 6. So divide both sides by negative 3. And I find out that y is the same thing as 2. Well, now I know what one of my y values is. Or sorry, one of my variables. I know what one of my variables is. So I can go back up into either equation. It doesn't matter. And I like the top one just because it looks a little bit easier. And I'm going to substitute in that y value of 2. Okay, so looking at this, I have an x plus 3y equals 5. Well, I already found out that y is 2. So x plus 3 times 2 is 5. So x plus 6 is 5. And subtract 6 from both sides. And x is negative 1. So now I have an x value and a y value, which means I have just figured out that this is a consistent system. It is consistent, and I know where it hits. So I know that my x coordinate is negative 1, and my y coordinate is 2. So if I were to graph these two lines, they would cross at the point negative 1, 2. So we're going to use elimination to find this answer and work through it this way. So elimination means I'm going to work vertically. Okay, so I want to either kill off my x's or I want to kill off my y's. and it doesn't matter which one you choose to kill off. So I'm just going to go ahead and decide to kill off my x's. So if I'm working vertically, notice that this one has a -6, which means if this was a +6, then a -6x's plus 6x's would kill off my x's. So how do I change a 2x into a 6x? I'm going to multiply it by 3. So the way I'm going to write this is I'm going to write little notes to myself, and I'm going to take 3 times row 2. And that just helps me keep track of what I've done. Okay, so the top row isn't going to change. So I've got a -6x minus a 3y is a -75. But now I'm going to take 3 through this one, this one, this one. Okay, so if I take 3 times 2x, that gives me 6x. If I take 3 times 6, I get 18 y's. And if I get 3 times 70, I get 210. And now look at this magic. When we work vertically, -6x's plus 6x's is no x's. Okay, 18y's minus 3y's is 15y's. And 210 minus 75 is going to be 225. Okay, so now I've taken all of this mess and I've gotten just to this far, which means I can figure out what y is. So I'm going to divide both sides by 15, and I'm going to figure out that y equals 15. So again, this is a consistent system. So I already know, we'll just write this over here. I already know that my y coordinate is 15. So now I need to find my x coordinate. Well, remember, this point is where these two lines meet. So the x coordinate will be the same for both of them. So I'm going to grab either equation. I think the bottom one looks a little bit easier, so I'm just going to grab the bottom one. Okay, so 2x plus 6y is 70. Well, I know what y is. It's 15. So 2x plus 6 times 15 is 70. So 2x plus 90 is 70. And I'm going to subtract 90 from both sides. So 2x equals -20. Divide by 2, and we'll get x is -10. So I have a consistent system, and these two lines, if I were to graph them, would cross at the point -10, 15.